Everyone has heard of a pixel or pixels, but do you know what they are or how they really work to allow you to see digital pictures and videos? Every electronic device, TVs, desktop computers, laptops, smartphones, anything with a screen, uses pixels to convey images to your eyes and brain. What is a pixel? Let us start by saying it is composed of 3 parts, called subpixels. That probably doesn't help much, but it is true and important. One subpixel is red, one is green, and the third one is blue, in that order, left to right. These are red, green, and blue sources of adjustable intensity light. The mechanism for producing the light comes in various kinds, which is beyond the scope of this video. For this presentation, I will call them light bulbs. In fact, in a large number of cases, they are actually LEDs, light-emitting diodes, which are really the semiconductor version of little light bulbs. That's what a pixel is. Let's assemble a very large pixel so you can see it. Red, green, and blue. On a black background. 3 variable brightness light sources in the shape of a rectangle, next to each other, with a much smaller black space between them. The actual size of the average pixel is about 1/100th of an inch, or 0.01 inches. The size can vary greatly depending on the device, usage, etc.
Here's what a group of pixels would look like magnified a few times over a small white area on the screen. The magnifying glass will grossly distort the shape, but in reality, it really is a nice equal even pattern over the entire screen as shown in this magnified fragment of a screen. I'll put up a white square on the screen. Pause the video and look at the white square with a good magnifying glass with at least 10 times magnification. You will have to get close. You should see tiny red, green, and blue rectangles just like the pattern. Now, how does this pattern of red, green, and blue rectangles get adjusted so we see full color moving pictures? Remember, these colors are always red, green, and blue, no other color, in no other order. Anyway, how does it work? It's magic! Alright, not really, but it is trickery. More interactive demonstrations that you can participate in are coming up, so stay with this video. It all works because our eyes and brain have built-in limitations. The technology tricks our eyes and brain into seeing all the different colors just using the red, green, and blue combinations at different intensity levels. Illusions of motion are also created this way, by changing just the intensity of each subpixel in a controlled order. Use the magnifying glass again to look closely at the red, green, and blue circles. Then look at the 4 other colors at the intersections of the 3 circles. This includes the white center, which is the intersection of all 3 color circles. Pause the video now. Without any other medical, biological, or physics explanation, the further away we are, or the smaller the points of light are, the more the eye and brain combination mixes the frequencies of the red, green, and blue light together to get another frequency, or color. Now let us take a different approach to see what the pixels are doing. For this phase of the demonstration, you will need to pause this video and step back from your monitor several feet when directed by this presentation. When indicated here, pause the video, then slowly back away from the computer while watching the pattern presented on the screen. When you get about 10 to 20 feet away, the 3 subpixel colors will blend to form a white square. It may not be perfect, but hopefully, you will get the idea. Slowly walk back to the screen and watch the red, green, and blue subpixels appear again. When finished, resume the video. Pause the video now. Now I'll make the pixels normal size again so you don't have to move away from the screen. Do the same procedure with the green pixel off. You will notice some color combining takes place before you start moving away. Pause the video now. Now I'll make the pixels normal size again so you don't have to move away from the screen. Do the same procedure with the blue pixel off. Pause the video now. Now I'll make the pixels normal size again so you don't have to move away from the screen. Do the same procedure with the red pixel off. Pause the video now. Now I'll make the pixels normal size again so you don't have to move away from the screen. Here are 4 random colors to look at with the magnifying glass. Notice the different intensities of the red, green, and blue subpixels.
The following conclusion to this video are a few interesting details concerning pixels and everyday devices.
A 1920 by 1080 pixel television panel, computer screen, etc., has over 2 million pixels, 2,073,600, lined up in 1920 columns by 1080 rows. The aspect ratio, width versus height, of the 1920 by 1080 screen is 16 by 9. There are many different aspect ratios used by different devices. Just look at all the different shape screens on devices you and others use. A 1080 by 1920 pixel screen, otherwise known as HDTV, has 2,073,600 pixels times 3 subpixels equals 6,220,800 little light bulbs that are separately controlled by the video computer. In this case, my old 55-inch LG television. The values of each bulb are updated to one of 256 values, 30 times every second. This is how you get illusions of motion. By the way, 3 subpixels at 256 brightness levels each equals 16,777,216 unique colors and brightness levels from just the 3 primary colors, red, green, and blue. A typical computer screen has 70 to 130 pixels per inch but can be more or less depending on the manufacturer, model, purpose, etc. A typical smartphone has many more pixels per inch to get a good high-resolution image in a small space. Like my Galaxy A13, which has 425 pixels per inch. My LG TV mentioned previously has 40 pixels, or dots, per inch. As a contrast or reference point, the big massive ball-shaped theater in Las Vegas called the Sphere has 1.23 million pixels spaced 8 inches apart, spread over a 580,000 square foot partial sphere. Up close, these are many clusters of large LED bulbs varying in intensity over a period of time. Far away, it is a huge television screen with giant moving pictures.
Anyway, that is it for this video. Hope it was entertaining and useful.